Hello everyone. Today we are going to discuss about 8085 interrupts. Here the contents of the video is, first of all we will discuss about interrupts, then 8085 interrupts, then about trap, then interrupt vectors and vector tables, and then the references. Interrupts. Interrupt is a process where an external device can get the attention of the microprocessor. Means any task which is executing by the microprocessor can be halted in middle and some other processor will take the microprocessor. The process starts from any IO devices and it is asynchronous. Means it can occur at any point of time and it may be due to any IO devices. We can classify the interrupts into two categories. First is maskable interrupts and another is non-maskable interrupts. Maskable interrupts are those interrupts which can be delayed or rejected or paused for a time. Non-maskable interrupts are those interrupts which cannot be delayed or rejected and hence it cannot be paused. Means when a non-maskable interrupt is generated, it can processed at the same time. Interrupt can also be classified into two categories, vectored and non-vectored. Vectored interrupts are those interrupts which are generated by any hardware and their addresses are already predefined. Vectored interrupts are predefined interrupts, whereas non-vectored interrupts are those interrupts which are not predefined. Means at the time of their occurrence, the address of that interrupt is mentioned. Now, what happened when a microprocessor is interrupted? As soon as an interrupt is occurred, the microprocessor receives the signal and suspends the current executing program and it jumps to the interrupt service routine where that interrupt will be serviced. Each interrupt will most probably have its own ISR. ISR means interrupt service routine. Responding to an interrupt may be immediate or delayed. That depends on the type of the interrupt, means whether it is maskable or non-maskable. Now we are going to discuss about 8085 interrupts. We have already discussed about interrupt. Now 8085 has few types of interrupts called as trap, RST 5.5, 6.5, 7.5 and INTR. All these interrupts are priority based, in which the trap has the highest priority and it is non-maskable interrupt. Then RST 7.5, 6.5 and 5.5 are there. The lowest priority interrupt is INTR. All these four types of interrupts, RST 7.5, 6.5, 5.5 and INTR are maskable. Only the trap is non-maskable. Trap and RST, these interrupts are vectored interrupts, whereas INTR is non-vectored interrupts. We'll discuss vectored and non-vectored interrupts later in the video. Now, we have discussed all types of interrupts. To enable the interrupt, EI instruction is there. EI instruction is used to enable the interrupt. DI instruction is used to disable the interrupt. Enabling the interrupt and disabling the interrupts are possible in case of non-maskable interrupts. The 8085 has single non-maskable interrupts, that is not affected by the value of interrupt enable flip-flop. Means non-maskable interrupt is that interrupt which cannot be masked. So 8085 is having only one, that is trap. This chart shows the name of the interrupts and their property, whether it is maskable or non-maskable, also whether it is vectored or non-vectored. Trap. Trap is the only non-maskable interrupt in case of 8085. It cannot be disabled. It has the highest priority among other interrupts. It is the edge and level sensitive, means it needs to be high and stay high to be recognized. Once it is recognized, it won't be recognized again until it goes low, then high again. Means once the trap is generated, then microprocessor will solve the query, and after that trap will goes low. Trap will, if the trap will not goes low, then microprocessor will not continue its previous work. Trap is usually used for power failure and emergency shut off purposes. Interrupt vectors and vector table. Interrupt vector is a pointer to where the ISR, that is interrupt service routine, is stored in the memory. All interrupts, whether it is vectored or non-vectored, are mapped into a memory area called interrupt vector table. Means once the interrupt is generated, it will go to that particular memory location. That memory location is represented using vector table. All the addresses in the vector table itself, interrupt vector table. The IVT is usually located in the memory pages 00, that is 0000H200FFH. This location is dedicated for interrupt vector table. The purpose of IVT is to hold the vectors that redirect the microprocessor to the right place when an interrupt arrives. Now the purpose is, if the address is already known of that interrupt, then it is very easy to solve that interrupt in a quick response. So interrupt vector table is used to store that addresses. For example, let a device interrupts a microprocessor using RST 7.5 interrupt line. Now, as the 7.5 interrupt is vectored, the microprocessor knows in which memory location it has to go using a call instruction to get the ISR address. Now, 7.5 is knows a call to this location which is already defined in the interrupt vector table. So microprocessor goes to the location and get a jump instruction to the actual ISR address, and then microprocessor will then jump to the ISR location. In this manner, the execution happens of the interrupt vector. The references to make these slides and video, I referred these two books of microprocessor. One is written by Ramesh S. Gonkar and another is written by Mohammad Rafiq Usman. These are the references which I have took for these slides and videos. Thank you everyone.